This video is for students that were absent on the second day of doing this activity and missed some of the things that we did together. So if I recall, this is what we did in class today. So we picked up in question 9, and I did some of the rewiring in class just to clarify what you should be seeing in that circuit. So in this one, you're moving the multimeter lead across both ends of the resistor. And so when you're looking at your multimeter, you should be connecting it at either end of the resistor, so you're only measuring the voltage across the resistor. And you're going to put that measurement right there. And just for clarity, you should have 5 volts on your power supply, and this number should be less than 5 volts. Okay, so whatever that number is should be less than 5 volts. It should be something very specific, but people had different resistors in there that was causing the numbers to be a little bit different. Right, now for part B, can you guess the voltage if you were to move the multimeter leads to measure the voltage of the resistor in the opposite direction? So what you're going to do is take your red lead and move it over here to where the black is connected, and take the black lead and move it over to where the red lead. Make your guess first. You're not going to be marked down if your guess is wrong, just like what do you think it's going to be if you switch the directions of the leads. Then go ahead and switch them and write down what you measure. Now, for the next part, can you guess the reading you will see when you move the multimeter leads across the LED only, then make your change? So you're going to take your leads, first make your guess, okay, and then orient them back the same way. So you're going to have the red and the blacks crisscross, like uncross them, okay? And then you're going to put the black lead so that it connects with the LED right there, and the red lead so it connects right there. Okay, and that number should also be less than 5 volts, and you should see a connection between your answer for 9A and what you actually measure for 9C. Okay, so that kind of talks you through step 9. For number 10, I'm going to see if I can draw on this. So we're going to use Ohm's law to do this. I'll pick a red pen maybe, and we'll see how this goes. So we're going to use Ohm's law, which is V equals IR, and we know our voltage is 3 volts, so we have a 3 for the V, and we're looking for the current, and we know that our resistance is 470. And so to figure out what I is algebraically, we just divide both sides by 470. And that ends up being, I had a calculator here, hang on a second. So what do we have? 3 divided by 470. And so the current is 0.006, and then it's like 3829, blah, 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 but we'll round it to 64 amps. And if you notice, that's really, really small. So one of the things that happens in electronics is when you're in your MKS system, that's your meters, kilograms, seconds, and your like base units, certain things end up always being really small numbers. And so this would often be done in milliamps, where you would move the decimal point 3 spaces to the right. And so you might say 6.4 milliamps instead. Now, we were doing part 3. I guess I need to click on something. There we go. Part 3, part 11 as a class. So be sure to show your work to the side. So we've got a circuit there. We've got 9 volts, and then we have these 2 470 ohm resistors in there. And when I draw these, like I always draw them with the battery on the left, because that's how my physics teacher did it. So that's how I always do it. So I always draw it like that. And we have 2 identical 470 ohm resistors are in series with each other. There is only one path through the circuit from the power source to the ground. In the diagram, the power source is a 9-volt battery. And the other end of the battery has, the next part is kind of like they haven't really gone over the vocabulary what 9 volts of potential is. That probably sounds super weird to you if you haven't studied electricity. So I'm just gonna, and the other end has 0 potential. Basically, it means you got power and ground. Okay. Based on your observations, what do you think? I don't want to get my circuit off there, so I'm going to read it off of the handout. Based on your observations, what would you expect the voltage to read if you connect the multimeter across the two resistors? So that means you've got your digital multimeter, okay, and you connect the leads here and here. So they're across the two resistors. And what I want you to notice about that is that your connection here is essentially connected to the positive terminal of the battery, and the negative is essentially connected to the negative terminal. So it's just as if you put the multimeter over the battery, so it would be 9 volts, okay? It's because there's nothing in between where you're measuring it and the terminals of the battery. Now, knowing that, this is part B, knowing that R1 and R2 are identical, what would you guess the voltage across each resistor would be? So as you're going through the circuit, you are losing some of that voltage. And so if you were to connect your multimeter here and just measure the voltage across the resistor, what would you expect it to be, knowing that the two resistors are equal? And so you can think about it for a second. It usually doesn't take too long for somebody in class to say, well, it would be 4.5 volts. So it would actually be half of the voltage. So what it's kind of like is like you've got 9 volts and you're losing half of it on the first resistor and the other half on the second resistor, so that you end up with 0 volts by the time you end up back at the negative terminal. And then part C, we can replace these two resistors with one resistor to have the same impact on the circuit. It's often called like an equivalent resistor or total resistance. And what would the value of that resistor be? When you have resistors in series, so if you took POE, then I think you do cover this. When you add resistors in series, you can just add them together. So that makes that 940 ohms. So you can take both of those 470 ohm resistors and replace them with one 940. So that should get you through number 11, which we did in class. Oh, did I not click on that? There we go. Okay. Now 12 and 13, that the class was on their own to do, so you are also on your own to do that. You can pull up your Tinkercads on your own, but notice what happens. You're going to hook up the series circuit like this, note what happens, okay, and why did it happen, and then you're going to, for 13, hook it up in parallel, and then remove one of the LEDs and say what happened. Okay, for 14, I do want you, you don't have to post the photo, okay, but I do want you to try to redraw this circuit in parallel form, okay, just on your own. Pause the video. Like, what would it look like if those two 470 ohm resistors were in parallel? Literally pause this video and do it like right off to the side, right over here. And now I will go over it. So in this spot right here, okay, you can go ahead and, well, I'm going to do this. I don't know what this is. I don't know what that is, but it's going to look cool. I'll give you like what it should look like. So what you should have done is you should have your battery, okay, and to connect them in parallel, most people will do it like this. Okay. But you can also kind of move it around, because in reality, your circuit isn't usually boxy like that. So you could do something like this, where you have one of them and then you could put the other one like up here like that, because like a wire is just a wire is just a wire. Now, physically speaking, if you were to actually physically build this, it probably, whoops, okay, wouldn't look like any of those. It would probably look like a wire connected to the terminal of the battery, and then you'd have another wire also connected to the terminal of the battery, and you just have like these two wires there, and they would be rounded and bendy, and you wouldn't have like square edges or something in it. So that's what it would look like. Now, the last question there, in a series circuit, all the components have the same current because there's only one branch for the current to flow through. And that is not the case for parallel circuits. So, but they do share something in common. So series circuits have the same current everywhere, or series components have the same current. Parallel circuits or parallel components also share something in common. And if you look at maybe this one over here on the right, both of these resistors, they don't necessarily have the same current because they're in two different wires, but they are connected to the same battery, which was I think it was a 9-volt battery. Okay, so they were connected to the same battery. So the answer to that is that they share the same voltage, because in parallel, you'll have the same voltage over both branches. Now, for this last part, there's actually 3 calculations that you need to do. I did one of them in class, so I will do one of them in this video so you can get caught up on that. But this is looking for, let's do this one. Okay, so this one is looking for the current in each branch of this circuit. So we have Ohm's law is V equals IR. We know that all 3 of these all have a voltage of 9 volts because they're all basically connected to the battery. So all of them have a voltage of 9 volts. We're looking for the current, and I'll do the 165 ohm resistor. And so we'll divide by 165. And where did I put my calculator? It's under the handout. Go me. So 9 divided by 165. So we have 0.0545. That looks good. Amps is the first current. And I think that was resistor 1, so we'll call it current 1. So you've got to do that 2 more times for the other 2 resistors. And while you're doing that, kind of notice which branch of it is getting the most current. Okay, and be wary of decimals. I just graded everybody else's and we had some decimal errors there. So that should take you through kind of the in-class part that you missed. Let me know if you have any questions.